Imagine your app suddenly goes viral. Yesterday you had 100 users. Today you have 100,000 users. At first everything looks fine. Then the API starts slowing down. Login takes 10 seconds. Orders fail. The database is screaming. And now you have one big question. Do you buy a bigger server or add more servers? That decision is the difference between vertical scaling and horizontal scaling. And if you choose the wrong one, your backend can become expensive, fragile, and very hard to fix later. So in this video, I will explain the difference using a real backend example. Let's say we have a Spring Boot application. It has a REST API, database authentication, and maybe mobile or web client calling. At the beginning, everything runs on this server. The Spring Boot app is here, the database is here, user sends a request, the server responds. Simple. But as traffic increases, this one server starts reaching its limit. CPU goes up, memory goes up, requests become slower. And now we need to scale. There are two main options: vertical scaling or horizontal scaling. Vertical scaling means making the same server more powerful. So instead of using a server with 2 CPU cores or 4 GB RAM, you upgrade it to 8 CPU cores and 32 GB of RAM, or even more. You are not adding more servers, you are making one server stronger. That's why vertical scaling is also called scaling up. A simple example about this: your Spring Boot API is slow because the server CPU is always at 90%. So you move the app to a bigger machine. More CPU, more memory, better performance. Same application, same architecture. This is usually the easiest scaling option. You don't need a load balancer. You don't need multiple instances. You don't need to think too much about the distributed system. You just give your app more resources. For example, imagine your API endpoint for getting products. At first, it handles 50 requests per second, and then traffic grows, and now it needs to handle 300 requests per second. If the server has enough room to upgrade, vertical scaling may solve the problem quickly. You move to a stronger server, and the API can handle more traffic. That's why many projects start with vertical scaling. It's simple, fast, and for small to medium applications, it can work very well. But there is a problem. Vertical scaling has a ceiling. At some point, you can't keep buying bigger servers forever. There is always a maximum CPU, maximum RAM, maximum disk performance, and the bigger the server gets, the more expensive it becomes. Another problem: you still have one main server. If that server goes down, your application goes down. So vertical scaling can improve performance, but it doesn't automatically improve availability. You made the server stronger, but you didn't remove the single point of failure. And this is where horizontal scaling comes in. Horizontal scaling means adding more servers instead of making one server bigger. So instead of one powerful server running your Spring Boot app, you run multiple instances: Spring Boot app instance 1, instance 2, instance 3. And in front of them, you add a load balancer. That load balancer receives an incoming request and distributes them across the available servers. That is called scaling out. Now, if a 10,000 users are using your app, the traffic doesn't hit only one server, it gets shared. Some requests go to instance 1, some go to instance 2, some other goes to instance 3. And if traffic grows, you can add more instances. So for using the same endpoint, getting products with one server, maybe it handles 300 requests per second, but with 3 servers, maybe the system can handle much more because the traffic is now distributed. This is the idea behind horizontal scaling. So instead of asking how big can one server become, you ask how many servers can I add. That is much more flexible, and it's how many modern backend systems scale. But horizontal scaling is not free. It introduces new problems. When you run multiple backend instances, your application needs to be designed correctly. For example, where do you store user sessions? If a user logged in and its data is stored only in a memory of one server, you may have a problem. A user logs in through server 1, then the next request goes to server 2. Server 2 doesn't know the user is logged in. Now authentication breaks. That is why horizontal scaled apps usually need stateless authentication like JWT or shared session storage like Redis. Another problem is file upload. If a user uploads an image to server 1, but later server 2 needs that image, where is that file? This is why production systems usually store files in shared storage like S3 or another object storage service such as Google Storage. Another problem is database load. Even if you add more Spring Boot servers, they may all hit the same database. So the bottleneck moves from the backend app to the database. That means horizontal scaling often require better database design, caching, indexing, read replicas, or queue-based processing. So horizontal scaling is powerful, but it forces you to think like a system architect. Here is the clean differences between horizontal scaling and vertical scaling. Vertical scaling means you keep one server, you make it stronger, it's easier to implement, and it's good for early stage application. But it has a limit. It can still be a single point of failure. Horizontal scaling means you add more servers, you distribute the traffic. It's better for high traffic and high availability, but it requires better architecture. You need load balancing, stateless design, shared storage, and sometimes caching or messaging queues. Which one should you choose? In real projects, the answer isn't usually one or the other forever. Most applications start with vertical scaling because it's simple. You build the product, you get the users, you upgrade the server when needed. But as traffic grows and downtime becomes more serious, you move toward horizontal scaling. A good rule is if your problem can be solved by giving one server more CPU or memory, vertical scaling may be enough. But if you need high availability, traffic distribution, and easier growth over time, horizontal scaling becomes a better choice. For Spring Boot applications, this means you should design your backend early with horizontal scaling in mind. Even if you don't use multiple servers today, avoid storing important state inside the application memory. Use external storage for files, use proper authentication, keep your services stateless when possible, because when the time comes to scale, your architecture will be ready. The difference is simple. Vertical scaling is like buying a bigger truck, horizontal scaling is like adding more trucks. A bigger truck is easier at first, but more trucks gives you more flexibility when the load keeps growing. And in backend engineering, scaling isn't just about handling more users, it's about building a system that does not collapse when people actually start using it. In the next video, I can show you how to run multiple Spring Boot instances behind a load balancer so you can see horizontal scaling in action.